Testing on YouTube. 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 All right, YouTube is working. Testing on YouTube. Now we just gotta wait for X. Spit out this gum. All right, where are we at? I think it's live on X. Let's check, make sure. Is it? Is it live? Are we live? Does it work? Come on. On YouTube? Does it work? All right, where are we at? I think it's live on... Okay, I think it's live on X too. Perfect. Let's get this started. How's it going, Josh? How's it going, Blubber? Tom? Bioinfo? Is this stream topic a self-report? I don't exactly know what that means. How's it going, Head Patter? Let's get this started. How's it going, Economic Sanity? Bonjour. All right, guys, we got something a little bit different today. There wasn't a ton of papers. Paper was kind of slow. And it being 420, I was like, why don't we do something a little bit unusual, a little bit trippy? So we're going to be doing a stream which I'm calling Consciousness or Conscious Simulated Holograms. And we got a nice little boo here that has her third eye open on the backdrop of space. But we're going to be looking at a couple different papers that try to prod and poke at this type of question, specifically 4 papers. These are some of the more famous papers, so if you've never read these, you're going to come out of this stream having a much better idea about these. So we have Facing Up to the Problem of Consciousness by David Chalmers. We have The Interface Theory of Perception by Donald D. Hoffman. We also have Are You Living in a Computer Simulation by Nick Bostrom. And then we're going to close it out with an absolute monstrous paper called The World as a Hologram by Leonard Susskind. Okay, so these papers kind of lead one into the other, and they kind of gradually increase in complexity a little bit. So I'm going to start off with this one here. This one is Facing Up to the Problem of Consciousness by David J. Chalmers. David J. Chalmers is an Australian philosopher and cognitive scientist, professor of whatever at New York University, has a bunch of academic credentials, PhD, guy knows his stuff. All right. So he starts off with this introduction here. Consciousness poses the most baffling problems in the science of the mind. There is nothing we know more intimately than conscious experience, but there is nothing that is harder to explain. So this paper is all about trying to understand what consciousness means. Everybody loves to talk about consciousness, but it's such a vague word and it has such a array of definitions that it's very difficult to really pinpoint. And in this paper, he tries to kind of summarize that and then propose his own kind of theory around that. I critique some recent work that uses reductive methods to address consciousness and argue that these methods inevitably fail to come to grips with the hardest part of the problem. And already you're going to start noticing what I think is the biggest problem with this paper is that this guy is flowery with his language to the point that he kind of plays with you in logic space using words and analogies that don't necessarily answer the question. So he's not very scientific in this paper. He's basically like playing these logic games with words, right? And it starts off right here, right when he says, fail to come to grips with the hardest part of the problem. So coming to grips is an English expression about grabbing something and then it's slipping out of your hand. But that doesn't mean anything when you're talking about validating hypotheses, right? So, all right, I'm just starting to rant, but I have just the important parts highlighted. This is more of a philosophical discussion than the actual technical stuff. How's it going, Glass Cannon? So consciousness is an ambiguous term. It is useful to divide the associated problems of consciousness into hard and easy problems. So if you've ever listened to a Lex Friedman interview where he talks about the hard problem of consciousness, it means that he read this paper. So if you hear people bring that up, you'll understand what it means after we finish this stream. And then you'll also understand that it's a little bit of a cop-out and it's kind of like playing with words, but it's really not necessary. It doesn't necessarily mean that they know what consciousness is and you don't, right? They're just kind of finding a niche and using terminology that makes them sound like an expert, but when really it's not. So he breaks it down into easy problem and hard problem. So what he defines as the easy problem of consciousness is those of explaining the following phenomenon: the ability to discriminate, categorize, and react to environmental stimuli, the integration of information by a cognitive system, the ability of a system to access its own internal states, the focus of attention, and the deliberate control of behavior. And maybe one thing, this paper was published, when was this published? This is 1995, so quite old. This is way before any of the large language model kind of AGI stuff we have now. So from the 2024 lens, reading these, this is basically, all of these can be described by a language model, right? A language model can discriminate, categorize, and react to environmental stimuli. A language model is doing some kind of integration of information, right? That's what the layers of each of the little neural net are doing, right? They're integrating the information from the previous layers and producing some kind of compressed representation of that information that is then consumed by the next layer, and so on and so on and so on. LLMs can access their own internal states. They have a focus of attention. In fact, a key part of the model architecture of these language models is called an attention mechanism, which is specifically choosing which parts of your information are relevant to other parts of your information, and then using that to kind of feed information up the levels of the hierarchy. And then even an LLM has this kind of wakefulness and sleep difference, right? Where technically an LLM, if you turn it off, you could kind of think of that as it's sleeping. And then when it's awake, when you're performing inference and it's running, then it's awake. So kind of interesting that this 1995 paper describes kind of consciousness in a way that you could effectively drop in a language model and it says that the language model is conscious. So as Ilya said, it may be that these large language models are slightly conscious. Okay. All of them are straightforwardly vulnerable to explanation in terms of computational or neural mechanisms. But David Chalmers here says that there's a separate thing, which is what he calls the really hard problem of consciousness, which is the problem of experience, which is a subjective aspect, or there is something it is like to be a conscious organism. Okay, so he's basically separating, this is what people normally call consciousness, and usually they kind of, when people are arguing whether LLMs are conscious, they're basically arguing whether or not they possess one of these properties, which of these properties do they have, which do they not have, and so on. But then Chalmers says, okay, no, there's actually the real question around consciousness is what I call the hard problem of consciousness, which is the subjective or phenomenal aspect. So there's a couple different terms that people use to describe this. So if you've ever heard someone talk about phenomenal consciousness or qualia or conscious experience or simply experience, this is kind of what they're referring to, the hard problem of consciousness. Okay, let's keep going. The easy problems are easy precisely because they concern the explanation of cognitive abilities and functions. The hard problem is hard precisely because it is not a problem about the performance of functions. The focus of attention. Attention is all you need. Okay, we keep scrolling. Reductive explanations work in just this way. To explain learning, we need to explain the way in which a system's behavioral capacities are modified in light of environmental information, and the way in which new information can be brought to bear in adapting a system's actions to its environment. we show how a neural or computational mechanism does the job we have explained learning. So that makes sense to me, right? You're basically saying that if you can explain how the information that you feed into a language model produces kind of the functions or behaviors that it outputs when it's in a wakeful state, right? When it's performing this inference, then you kind of know what learning is, right? You know how learning becomes the function that you apply to your environment, which I agree. But the tricky part is that as we've moved from kind of expert systems and like hard-coded logic into this much more vague world of deep neural networks, we've lost some of that explainability, because even people who are like deep in this, right, like the Jan LeCuns of the world, they don't really know what the hell is going on, right? At the end of the day, it's like there's hundreds of these layers of abstraction that are producing these compressed representations that are just vectors of numbers. And do we really know what's going on at each of those layers? Do we really kind of have a definition that is satisfying for that? Not necessarily, right? So maybe we haven't really answered that. There's an explanatory gap between the functions and the experience, and we need an explanatory bridge to cross it. So as I'm kind of reading this paper, right, I hope you guys are kind of starting to catch on how this guy is playing with your brain a little bit, like the explanatory bridge, right? Like he's playing with words here in a way that makes him kind of, I don't know, I don't like the way he does it, but we're going to go into it. So he starts off with a number of works that have addressed the problem of consciousness within the framework of blah, blah, blah. So he's like, okay, here are other times that people have tried to explain what consciousness is. So he starts off with this 1994 Crick paper, Neurobiological Theory of Consciousness, which centers around a specific neural oscillation, 35 to 75 hertz. That's basically how many times are you going up and down per second, and this is in your cerebral cortex. So oscillations are the basis of consciousness. That's what these Crick and Koch guys are saying. Binding is the process whereby separately represented pieces of information about a single entity are brought together to be used by later processing, as when information about the color and shape of perceived objects is integrated from separate visual pathways. When two pieces of information are bound together, the relevant neural groups will oscillate with the same frequency and phase. So inside your brain, right, your brain is not one monolithic thing. It's really a bunch of separate modules that are doing separate things. You have a module that's responsible for your vision. You have a module that's responsible for your motor control. You have a module that's responsible for storing memory, and so on. And all of these are working together, but the output of each of those is kind of fed into parts of your brain that kind of receive the input from all these different modules. And then that's kind of what this oscillatory explanation of consciousness is that basically that locus where all that information from all the different modules of your brain are coming together, that's kind of what the consciousness emerges from, right? The feeling of being something, the phenomenal aspect of consciousness is merely the fact that you have a bunch of separate brain modules that are all kind of oscillating and producing these effectively compressed representations in some point in your brain that results in that experience. But Chalmers kind of uses a way out of this, right? And he's going to do this for pretty much all the examples. I'm going to show you more. He uses this question, why? Why do the oscillators give rise to experience? I don't know, why? Right? Okay, and then here's another information. Okay, so in a different book, this Bernard Bars, 1992, he says, okay, there's a global workspace, a central processor used to media communication between a host of specialized non-conscious processors. This is kind of similar to the oscillation kind of theory, but more around this cognitive accessibility kind of perspective. But then Chalmers also dismisses this again with the why question. Why should global accessibility give rise to conscious experience? And this is where I start getting pissed off, because this is not, you can't just say that, right? You can always use this word, WHY, is basically like a trap card that you can pull in any kind of logical argument that is the ultimate trap card. There's no answer to that, right? if you're arguing with someone and they're like, okay, well, I believe this, that you can always say why, and then they'll give you an explanation, and then you can look at that explanation and say, okay, but why? And then they can give you another explanation, and you can say, okay, but why? So you can pretty much kind of infinitely recurse any logical explanation with this why question. And I don't know, that kind of pissed me off, because it's like, you can't just dismiss every single theory by just always asking the word why, because I can just do that to you, right? So I can go back to his original premise here and say, the hard problem is hard because it is not a problem about the performance of functions. And I can be, okay, well, why? Why is it not a problem about the performance of functions? Okay, well, because blah, blah, blah. Okay, but why? So I can play this game too, right? So I feel like that's appease me a little bit, that's kind of, he just uses that why kind of trap card to just infinitely dismiss all of these things. Okay. So third option, after some details about information processing are given, experience suddenly enters the picture, but is left obscure how these processes should suddenly give rise to experience, such as explaining the structure of experience. Certain facts about structures found in processing will correspond to and arguably explain facts about the structure of experience. And this is true with neural networks, right? There's certain things that you can do and certain structures that you can find within the processing of the information that these deep neural networks do, right? We've all seen those things where we look at the intermediate representations and we can maybe look at them how they would be in an image, and then you can see kind of how the representations as you go up in the hierarchy, some of them actually kind of look like textures, some of them actually kind of look like lower level features that eventually become these higher level features. So there's some structures that you can find in the way that neural networks process information that can kind of explain facts about how this neural network is experiencing things, right? The structure of the experience of the neural network. But it tells us nothing about why there should be experience in the first place. So again, using that why trap card. This is a man who will just look at you in the face, and no matter what you tell him, he'll look at you and be like, but why? Dude is just as verbose as ChatGPT. Yeah, I agree with that. We've got some stuff here by work. It could be that individual consciousness is not a thing, it's more of a collective. Is it millions of cells die and new cells are born? Is a cell conscious? Maybe to some extent. Yeah, I'm kind of more... So, I mean, over the course of this stream, you're gonna kind of glean a little bit more insight about what exactly my view around consciousness is, but I tend to be more kind of emergent. I think that consciousness is just kind of... I actually kind of really like this kind of central global workspace kind of theory, where it's like really the feeling of consciousness emerges from the fact that the part of your brain that has a representation of you, that kind of like the ego part of your brain, doesn't have access to the kind of non-conscious specialized processors such as the vision module and your memory module and your ear kind of listening part, right? It's only capable of viewing compressed representations of those that are outputted from a little hierarchy of neurons, very similar to a deep neural network. So, I don't know, that's my view, but let's keep going here. And let's see what the Y man has to tell us. Okay. Non-algorithmic processing, this is yet another theory put forward by Penrose. Why should this process give rise to experience? So Penrose basically says that consciousness is mysterious and quantum mechanics is mysterious. So maybe the two mysteries have a common source. So basically Penrose says maybe there's some quantum effects in your brain, right? Where maybe you can't just explain it entirely based on neurons firing with some potential and then causing other neurons to fire. Maybe there is quantum effects in the brain that are resulting in this conscious experience. And sometimes other ways that I've heard this explained is with the theory that the brain is like a radio, right? So people that were born during the radio generation, one way that they kind of think about consciousness is that your body is like a radio, and then you're tuned to a specific kind of frequency, and that your consciousness is some kind of like space kind of permeated function that like is like tuning in to the radio that is your body, right? So if you destroy your body or you smash the radio, the the song is still playing out there, aka the consciousness is still out there in the ether, but your brain is really just kind of channeling it through some kind of quantum effect that we don't fully understand. And there is kind of interesting quantum effects. So one thing that I actually thought is pretty cool is quantum photosynthesis. If you guys have ever seen this. So quantum photosynthesis is the idea that photosynthesis is a quantum mechanical process that starts with a single photon of light. And this is actually really awesome stuff. But basically, people have figured out that there's quantum effects in the way that plants harvest energy from photons, and that there's some mechanism by which whenever the photon is going through the chloroplast, which is like the specific part of the plant cell that produces the energy from the sunlight, it should actually take a random path, but the path that photon takes is not actually random. It's actually going through a bunch of these little chloroplasts in a way that actually means there's some kind of quantum magic going on there, right? Because it's getting more energy than it should. I don't know, that's maybe not necessarily a great explanation, but nature is mysterious. There's all kinds of natural systems and living systems that have quantum effects. So maybe the brain has some kind of quantum effect, and that quantum effect is ultimately what's leading to consciousness. Quantum phenomena has some remarkable functional properties such as non-determinism and non-locality. So non-determinism and non-locality, there is actually good definitions for this in the Donald D. Hoffman paper, so we're going to jump to that. Let's see. Blah, blah, blah. Let's see if I can find this section here. Conditional probabilities. I actually think the Hoffman paper is much better. He's more of a scientist, so I think he's a little bit... I kind of like his writing style a little bit better. Let me see if I can find this. I want to find his explanation of non-locality. Space-time position, blah, blah, blah. Talking about Bayes. File icon is dragged. Okay, here we go. So, most physicists reject local realism. So, local realism is the doctrine that individual things in space and time have some properties, and those properties exist, right? And not only do those properties exist, but you can't mess with those properties from some other point in space and time. And that's not actually true, right? So basically, people have proven that you can entangle particles such as electrons, right? So distant objects cannot directly influence each other, which is locality, but they can. All objects have pre-existing values for all possible measurements before any measurements are made. So what this means, and the way that they've kind of proved this, is you take two particles, such as electrons, you entangle them such that basically they're related to each other, you pull them all the way apart, and then you say, okay, these two electrons that are a billion light years away, they have some property, such as spin, and once I measure the spin on one of them, I know the spin on the other one basically gets set. So it's like the property of spin, which if you believe in local realism should be independent of anything else. It should just be a property that is a property of the electron, and that's it. But here you're saying that, okay, no, that spin is dependent on the spin of some other electron, which is billions of light years away. So what is going on there, right? How are they communicating in a faster than light way? How is it that they both have a property which depends on each other, right? And that's kind of the rejection of local realism. This is a puzzle for proponents of faithful depiction, but not for interface theory. I think we're going to skip the interface theory. We're going to go back to Chalmers' paper here. Some interpretations of quantum mechanics. Consciousness plays an active role in collapsing the quantum wave function. So this is going more towards the simulation theory, where basically you are a conscious agent, and whenever you observe something, you're collapsing the quantum wave function, which is basically saying quantum wave function, the TLDR of that is that everything in the real world, everything in our material world is really a wave function that is in a superposition of many states, right? So the tree in the forest, when it falls and no one's there to see it, it's not actually there, right? It's kind of like the Schrodinger cat if the cat is in the box, but you haven't actually opened the box and you don't know whether it's alive or dead, the cat is both alive and dead, right? The cat is in a superposition of alive and dead, right? So all particles are in this quantum superposition, and maybe when you observe them, right, you collapse that wave function to some certain state. Damn, you guys are popping off here. I saw articles about this. If local realism fails, doesn't it follow that IID assumption in probability fails as well? Yes. To some degree, yes, right? If local realism isn't real, then it kind of, that's like a domino that breaks pretty much every other domino, right? Because so much of physics rests on this idea of like, okay, there is some actual property, there is some pre-existing value for some property, and I am measuring that, and then if I go and I measure it tomorrow, it's still going to be the same that it was because it's not changing. And if someone else in some other country goes and measures that property, as long as they keep everything else relatively the same, that property is still there, therefore they should be able to measure it, right? But if non-locality, which we've effectively proved is the case, then you probably can't be making a lot of those assumptions, right? And then maybe this whole idea of the scientific method where I can measure something and then you can measure something and then we can both verify that by measuring that thing, then therefore we've proven this thing. Like, maybe that's not even a valid process, right? Okay. But if you weren't annoyed, Chalmers hits us once again. But why? Why should this process give rise to experience? Okay, you do your thing. Reductive methods that explain a high-level phenomenon in terms of more basic physical processes, work well in so many domains. One can explain most biological and cognitive phenomenon as an automatic consequences of more fundamental processes. And here, he kind of takes a little tangent here. I think he also shits about it here a little bit later. In some ways, a theory of consciousness will have more in common with a theory of physics than a theory of biology. Biological theories involve no principles that are fundamental in this way. So biological theory has a certain complexity and messiness to it, but theories in physics, insofar as they deal with fundamental principles, aspire to a simplicity and elegance. So I think this is a good little point here because he's kind of making you realize that in biology, or in many of the natural sciences, except for something like physics and math, we usually take down something that we don't understand, we break it down into little subparts, and then we try to explain each of those little subparts. And if we can explain each of those little subparts, then we can say we understand the whole, right? So if you can take a car engine and break it into each of the pieces and understand how each of the pieces work, then you can say, okay, I actually understand how a car engine works because I understand how each of the pieces work. But Chalmers is basically saying you can't do that. That only works for biology and for blah, 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 but you can't do this with consciousness, which to me, that seems kind of arbitrary, right? Like, why can't you do that, right? Why can't I sit there and say, okay, if I can take a human brain and I can explain fully what every single neuron is doing and what every single part of the brain is doing and how they all come together to produce this final behavior that is the experience of consciousness, can't I just say that now I know what consciousness is, right? I don't know, that's kind of my view, but Chalmers doesn't agree with that. Conscious experience is not the kind of thing that a wholly reductive account could succeed in explaining, but the only way you can explain things is by reducing it into parts and then explaining each of the parts. So, I don't know. In physics, it occasionally happens that an entity has to be taken as fundamental. Fundamental entities are not explained in terms of anything simpler. That's a good point, right? I suggest that the theory of consciousness should take an experience as fundamental. Experience itself is a fundamental feature of the world alongside mass, charge, and space-time. Okay, so he's basically saying that this kind of has a flavor similar to the Gödel's theory of incompleteness, right? Maybe it's not a good time to bring this up, but there was this guy in the early 1900s called Gödel who basically proved that math is bullshit. And what he proved is that you take any kind of formal system, such as math, where you have certain rules and you have certain things, and at some point, if you keep digging deeper and deeper and deeper, there's going to be some set of axioms, or basically some set of like definitions that you can't explain, right? So it's kind of like using the way that Chalmers here is kind of taking every single explanation and then just adding the question why. You can do that all the way down. And at some point, you're going to hit kind of the rock bottom where there's no answer to that why question. And here, in this point, he's basically saying that in physics, we're actually okay with that kind of thing. And in physics, let me jump around here. Blah, 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 blah. Works so well. Where was I? Right here. No, I'm getting lost in this paper. I'm already lost. Here we go. Fundamental entities. So, for example, mass, charge, and space-time, right? Mass. Things have mass. Gravity is a thing. What if you ask the why question? Why is gravity a thing? No one can answer that. Okay, why do things have electric charge? Nobody can answer that. Why is space-time a thing, right? Nobody can answer that. So much like Gödel proved that math is bullshit in the sense that at some point you're going to find some kernel there that you can't explain why, physics also has that same property where at some point you're going to get to the point of mass. Okay, but then why do things have mass? Why do things have charge? And there's no explanation to that. So you just have to kind of say, okay, that's fundamental. That's our bedrock. We can't go lower than that. There is no turtle upon which this turtle sits, right? If it's turtles all the way down, at some point there's the lowest turtle, and that turtle is that, okay, there's charge, there's mass, and there's space-time. And Chalmers is basically saying, okay, experience is in the bottom, is at the very bottom turtle as well. So if you try to use biology to explain the different parts of the brain, at some point you're going to get to the thing of like, okay, well, why do we have experience? Just assume that it's fundamental alongside mass, charge, and space-time, which I feel is like very unsatisfying. But taking experience as fundamental, there is a sense in which this approach does not tell us why there is experience in the first place. But this is the same for any fundamental theory. Nothing in physics tells us why there is matter, but we do not count this against the theories of matter. In some ways, this is the section I read before. Okay. Turtles all the way down, Spiral Bell. Causality is real so long as we observe things. Maybe. Okay. Just stopping real quick to see what you guys are saying. All right, so now he basically spends the first 15 pages of this paper kind of dismissing every other theory of consciousness with this why kind of logic, right? Kind of the why trap card, as I called it. And now he's going to go into his theory of consciousness. Okay, so conscious experience is not directly observable in experimental context, so we cannot generate data about the relationship between physical process and the experience at will. Okay, keep scrolling it. We can think of awareness as direct availability for global control. Okay, so now in his little definition of, or in his theory of consciousness, he starts breaking stuff down into what he calls structure of consciousness and structure of awareness. So immediately, right, he spent the whole beginning of this paper shitting on people for taking a hard thing that's hard to explain and breaking it into problems so as to explain each of those little individual things. And then here he is doing the same exact thing, taking consciousness, breaking it down into like, okay, well, actually we have awareness and we have consciousness. You're doing the same thing everybody else is doing. I could use the same arguments that you used earlier in the paper to dismiss everyone else's stuff, to dismiss the stuff that you're presenting here. Whenever information is available for report and for global control, there is a corresponding conscious experience. Thus, there is a direct correspondence between consciousness and awareness. Okay. Internal mental images have geometric properties. Emotions have structural properties. So properties, aka you're breaking down emotions into properties, right? Emotions, you can classify them. There's some structure there. You can create some structure or some inductive bias that allows you to better represent emotions. You can break emotions and mental images down into little component pieces that are easier to understand. The process that explains awareness will at the same time be part of the basis of consciousness. Okay, that's also kind of a non-statement because you're basically saying, okay, well, we can't explain consciousness, but consciousness is made up of awareness, and if we can explain awareness, then we can explain consciousness. But awareness is kind of equally vague as consciousness. I don't know. As you can see, I'm already seething. A silicon isomorph of a neural system might be impossible for technical reasons. Is it? Right? This paper was released pre-deep learning revolution, and it seems to me that we kind of do have a silicon isomorph of neural systems, right? A deep neural network, it doesn't have the same modules as the brain, but fundamentally it's the same thing, right? It's just basically neurons that fire based on the neurons before them that fire based on the neurons before them that fire. So you have a hierarchy of neurons that can take information in from the world and then compress that and represent that in increasingly better and more compressed ways, and ultimately produced some output behavior, right? So isn't that a silicon isomorph of neural systems? And don't they behave in a way that is very similar to consciousness? So information states embedded in an information space. This has also made me think of embeddings, right? So whenever you take an image and you encode it with an image encoder, such as the clip image encoder or the dyno image encoder, you're producing some vector. That vector is effectively representing that image, and it's embedded inside a space of all possible vectors that represent images, right? So all images in the world project to some point in this clip embedding space, and that clip embedding space is in fact a type of information space because it's embedding the space of all possible images. So a lot of the stuff that he's saying here actually kind of has direct kind of analogies and correlates to stuff that we see in machine learning and deep learning. Okay. An obvious question is whether all information has phenomenal aspect. Where there is simple information processing, there is simple experience, and where there is complex information processing, there is complex experience. So a mouse has a simple information processing structure than a human and has correspondingly a simpler experience. Perhaps a thermostat, a maximally simple information processing structure, might have maximally simple experience. And this is kind of more, now we're finally getting somewhere. Now we're kind of getting to the theory of consciousness that I kind of have, which is that everything is technically conscious. It's just that consciousness is a very complicated space, right? It's not a single, it's not a binary. It's definitely not a binary where you're either conscious or you're not conscious, and humans are conscious, but everything else is not conscious. It's not a one-dimensional thing where, okay, humans are more conscious than a rock or than an ant, which is more conscious than a rock. I think it's a multi-dimensional space, right? So the consciousness of a human compared to the consciousness of a dolphin, compared to the consciousness of an ant, they're different types of consciousness, but every single one of them is conscious, right? Because if we just think of anywhere where there's information processing happening, there is experience, and anywhere there is experience, there is consciousness. So then technically the rock has a type of consciousness, and technically a language model has a type of consciousness, which I think is kind of the better way to think about it. But ultimately, we get to the conclusion of this paper. The principles of structural coherence and organizational invariance will be planks in any satisfactory theory of consciousness. To make further progress, we will need further investigation, more refined theories, and more careful analysis. Okay, so my overall summary of this David Chalmers problem of consciousness, sometimes also called the hard problem of consciousness paper, is that it's kind of a bunch of nonsense. It's 22 pages or 27 pages of using kind of a cheat trap card of like using why, right? He basically says, okay, here's all the other theories of consciousness I'm going to say. They don't work because I can just always ask the why question. Extremely unsatisfying. And then I'm going to take my own theory of consciousness by using the same strategy that I just said nobody else can use. So I don't know, it's 22 pages of just mental masturbation that doesn't necessarily lead anywhere, but I think he has some good kind of nuggets here that are worth thinking about, such as the nugget of this physics having fundamental properties and whether that invalidates everything. So I don't know, that's my TLDR of this David Chalmers paper, and we're going to move on to the next paper. Interface theory of perception. Question from Pratyush. Do you see a black and white boundary between agentic systems, observer and experiencer, and could they be collectively making consciousness? I think that everything is agentic to some degree, right? Like, agenticness is just one of the many dimensions of consciousness, right? So if you compare the consciousness of a human to a cat, right? The cat, or let's do something else. Let's do an orangutan, right? Orangutans are primates that are very solitary, right? And let's actually compare the consciousness of an orangutan to consciousness of an ape or a chimpanzee. A chimpanzee is a very social type of primate. So inside the consciousness of that primate, of the chimpanzee, there is an awareness. There is an awareness of social situations, right? So when a chimpanzee is doing anything, it's always constantly aware of, for example, its place in a social hierarchy, right? It's aware of like, okay, this chimpanzee is my boss, this chimpanzee is my mom, this chimpanzee is my child, right? So it has a kind of awareness of a social hierarchy versus an orangutan doesn't really have that, right? An orangutan is not thinking about where it lives in some kind of social hierarchy because it largely lives by itself. But an orangutan might have consciousness that is better than a chimpanzee in a different dimension, right? So, for example, why are humans generally really good friends with dogs, and why do we feel like dogs have a similar type of consciousness to humans? It's because dogs are also social animals, so they also have a kind of social awareness, and that social awareness means that if you look at the space of all possible consciousness, the point at which dogs are is very similar to the point at which humans are. Humans just have a level of social awareness above that, right? Because humans can also consider their position not only in their local social group, but also in the social group of like humans that they've never even met before, right? So we have a type of social awareness that is beyond any other type of animal. But that's just one of the many dimensions of consciousness. Agenticness means it has to be non-deterministic, or can something be conscious and follow deterministic rules? Can something be conscious and follow deterministic rules? What does deterministic rules mean? Right? That kind of boils down to the question that Chalmers was asking around, okay, if you can explain all the things, does that mean that you explain the bigger thing, right? So if I can take a neural net and look at what every single neuron is firing and saying, okay, well, this neuron right here in your visual cortex, the reason that this neuron fired is because these 4 neurons, which are connected to that neuron, 3 of them fired and 1 of them didn't. So the fact that 3 of them fired means that the neuron there is going to fire, and it fires, right? So if I can explain what every single neuron in your brain is doing, and every single neuron in your brain is just following some deterministic rule, where is that agenticness that you feel coming from? I don't know, right? Okay. Chaos theory. That's kind of what economic sanity there is talking about, is kind of starting to get to the point where of what Penrose was saying, right? Where Penrose is saying that in this paper that there's some quantum effect, and maybe that quantum effect is where that randomness comes in, and that randomness is why humans are not entirely deterministic. Okay, but we gotta blast through this because we're already an hour in, and I wanted this stream to be a little bit shorter. So we're gonna go into the interface theory of perception by Donald D. Hoffman. Donald D. Hoffman, this guy does a lot of podcasts. He's a professor of Professor of physics, philosophy, whatever. Department of Cognitive Sciences, University of California, Irvine, blah blah blah. Bunch of academic credentials. This guy goes all around the podcast circuit to talk about his kind of pet theory, which is this interface theory of perception. So his interface theory of perception is that our perception constitutes a species-specific user interface that guides behavior in a niche. And he loves this analogy of the PC interface hiding the complexity of the computer. So he starts off the paper with this kind of shitty analogy about beetles that are confused about beer bottles. So basically they think that beer bottles are other beetles and they try to have sex with these beer bottles, but I thought that was kind of a weak way to start it. So we're just going to go straight into it. Hoffman says there is a local maxima of fitness. So this whole paper is thinking about the problem of consciousness around and kind of what you see and whether that is a true reality based around evolution. So he's thinking about this in a very evolutionary way. So you have this idea of fitness, right? Evolution is basically a process by which your organisms or your agents within some system are being evaluated on their fitness, which is their ability to kind of survive. So the organisms that can survive are the ones that can basically find a maxima in the fitness function defined by their environment. The fitness function, however, is not just going to depend on one factor, but on numerous factors, including the cost of classification errors and the time and energy required to compute a category. Okay, so where he's going to ultimately lead with this is that he's ultimately going to say that those two things, right, the cost of classification and the time and energy required, means that any organism is not actually going to be seeing true reality. What it's going to be seeing is some low-dimensional representation of reality that means that the time and energy required to process that information is smaller, right? It's kind of one way to, another thing to think about on this vein is that when you look at your visual field, most of that is actually kind of imagined, right? That you really only see the part of your visual field that is actually real and is actually being updated from the environment is actually very small compared to most of your visual field. And part of that is because it would take a lot of time and energy to constantly compute the full 4K resolution of your view, right? So usually you're just seeing a small kind of part of that is being updated, refreshed, and then most of your visual view is kind of just imagined. Okay, I'm kind of getting a little bit too deep. Let's keep going. We define vision as a perceptual inference, the estimation of scene properties from an image or sequence of images. There is a physical world that has objective properties and a statistical structure, and vision is estimating, recovering, and reconstructing that. And already there is a problem here, right? Because we know that the world does not have objective properties, right? That's the whole point of local realism, is that there actually is no objective properties. The properties exist in some quantum superposition and then they collapse into some specific objective state when you observe them, but if you're not observing them, there is no objective properties to see. Bayesian ideal observer theory, which combines different sources of information in an optimal manner in order to achieve effective deterministic outcomes. The primary function of perception is generating a replica of the external world in an internal representation, which I don't agree with either, right? I think that the function of perception is to create a low-dimensional compressed representation of the external world, which is easier to deal with and easier and quicker to compute with, right? Which we do in computer vision all the time, right? We generally don't feed full images into a language model. If you're doing a vision language model, what you're doing is you're first taking that image, feeding it into an image encoder, compressing it into a representation, which is a compressed representation of the actual image. But that compressed representation is lossy, right? It's not capturing everything in there. It's just capturing kind of the essence of it. Evolutionary speaking, visual perception is useful only if it is reasonably accurate. I kind of agree with that. But Hoffman does not. Natural selection optimizes fitness, not veridicality. So Hoffman basically says what you see is not the actual state of the environment, because ultimately you're going to live and die based around evolutionary principles, and evolutionary principles want you to basically create a lossy representation of reality that maximally helps you reproduce or achieve a good fitness score. And he says that there's a problem here. Conflating fitness and accuracy, they're not the same, and as we shall see with simulations and examples, they are not highly correlated. I disagree with that, but I like that he's talking about Bayes. So Bayes is basically statistics, right? Bayesian statistics is pretty much everywhere in machine learning. If you need a little refresher about Bayesian statistics, here is the basic Bayes formula here. You have the conditional probability. So you have P of W given I is equal to P of I given W. So P is the probability of a thing. And then this bar means that the probability of this thing conditioned on or given the fact that you already have this thing. So what is the probability of W given you have this I? So I might be a movie of some dots, and W might be some various non-rigid interpretation of those dots. So PW is called the prior. So this models the assumptions that human vision can make about the world. PIW is called the likelihood, so this part here. This is the models, the assumptions that the human vision makes about the world, how the world maps to images. PI is the scale factor, which is normalizing the probabilities, and PWI is the posterior. So Bayes' theorem is relating the prior to the likelihood and the posterior. According to conventional theory, we can simply go out and measure the true priors and likelihoods in the world. And in machine learning, a lot of times what we do is we actually assume that the prior is something like a Gaussian, right? We assume a prior. So Bayes' circle here, and this is Hoffman basically saying that there's kind of like a logical fallacy here because you're kind of using a thing to define a thing to then use that thing to define a thing. Using our measurements of priors and likelihoods to justify our posteriors leads to a vicious cycle. So because you can only see the world through your posteriors, and then because you measure your priors and likelihoods through that, that means that you're kind of in a loop there where you're kind of assuming priors based on what you're seeing, which is a function of what your priors are, which is based on what you're seeing, which is a function of your priors. So it's kind of this like loop that kind of ends nowhere. Conditional probabilities turn up everywhere in perception because perception is often about determining what the best description of the world or the best action to take given the current state of sensoria. Bayes is simply the right way to compute conditional probabilities using prior beliefs. But if you don't believe that those priors are correct, then Bayes kind of falls apart because it needs those priors to be good. It's kind of like a chicken and egg problem. If you don't believe that the egg is valid, then the chicken that comes out of that egg is not going to be valid, and the egg that is laid by that chicken is also not valid because the original egg isn't valid. I'm blasting through this, but let's see if you guys have any questions. If we consider modern LLMs are conscious, which parts of the code or architecture do we think contribute to the consciousness based on previous paper hypothesis? I would say the consciousness of a language model is coming from the fact that it is aware, and the awareness of the language model comes from the fact that it's auto-regressively producing tokens. So each token that a language model creates is based on the previous token that it created, and that's based on the previous token, and that's based on the previous token, and that's based on the previous token. So you can kind of, it's aware of what it's outputting when it outputs a thing. So the function that outputs tokens is aware of previous tokens. It's aware of the previous things that it's outputting. And I think that property of awareness is why I feel like LLMs are conscious. But I'm kind of using Chalmers' mental framework there to argue for that. Okay. Interface theory of perception, which is Hoffman's theory here. The perceptions of an organism are a user interface between that organism and the objective world. Okay, and this is where he basically, the analogy that I like the best, he has a beetle analogy that he uses, but then he also has this other analogy, which is the icons on a computer, and I think that's the better analogy. So in his analogy here is, let me see if I can find it. Dueling between these interfaces, competition. No, I want the icon analogy. Where is the icon analogy? Yeah, okay. So he talks about how the icons on a screen don't actually represent what's going on in the computer, right? Your computer is a bunch of transistors, which are either in a 0 state or in a 1 state, and you're interfacing with the computer via this screen that has icons and has a mouse, and you're moving this mouse around and clicking on icons, and there actually isn't an icon and a mouse, right? So when a file icon is dragged into the trash and disappears from the screen, is the file itself destroyed, or is it still intact and just inaccessible to the user interface? Technically, when you delete a file, what you're doing is dereferencing it, so the memory that was holding that file will still have that file there until it is overwritten. Right, and that's actually an important point. When you wipe your hard drive, you can't just delete the things, because then if you just delete the things, you're just dereferencing that memory, and somebody else could still go into that hard drive and pull out your files from that. So if you actually really, really want to destroy your files, what you need to do is basically overwrite them with noise. And you should deban. This is what you need. So if you ever donate your computer, make sure to run this on it. This is a project. You put it on a hard disk, or you put it on a little USB stick, and then you boot your computer. And what it'll do is it'll overwrite all the memory on your computer and with basically noise. Because if you don't do that, somebody could actually still take your hard drive and find your files in there. They're just not referenced, right? So this will actually overwrite it all with noise. So if you guys ever are afraid of the FBI raiding your house, have a little USB stick with D-band on it and just plug it into all your computers, overwrite everything with noise. Okay. So this is his interface theory of perception. And his kind of point here is that space, time, position, and momentum are among the properties and categories of the interface of Homo sapiens that in all likelihood resemble nothing in the objective world. So he's basically saying that much like the icons on a computer and the mouse on a computer don't actually represent the information in the computer in terms of the actual transistors that are flipping on and off in your computer, space, time, and position and momentum, all these fundamental physical properties, which according to Chalmers are basically the lowest turtle in this chain of turtles, are themselves much like the icons, right? They don't actually represent the objective world. But there's just so many different things that are kind of wrong here with this that it's a little sketchy, right? Because to me, it's like, okay, well, in this statement, there is an assumption that there's some objective world, which we already know is not necessarily true. And there is something there, right? Because whenever you are moving your mouse around, there is some transistors that represent the state of your mouse, and those are changing as you move your mouse. There is transistors that represent the fact that there is an icon, and that icon actually has a specific location in memory. And when you delete that icon, that specific location in memory is changing. So he's kind of like, I think there's holes in this interface theory that he kind of glosses over with words in this very similar way to Chalmers. And that's kind of one thing that I found myself again and again when I was reading these papers, is that these guys are just playing with words to get to their points, but it's like, I don't feel like you can necessarily do that. I don't know. LLMs are deterministic, and they show that most thoughts are deterministic too. Society is one big context window. Yeah, I agree with that, Spiral Bell. Basically, you are, as individual as you think you actually are just being programmed. You were programmed. Ever since you were born, all the information that you've consumed has populated the context of your mind, right? You've basically burned your experience into the weights of the neurons in your brain, and what you think is original is actually just output that is based on what you've had as input. So in a sense, your consciousness and your feeling and like the things that you like and the things that you think you want and the things that you think you don't want, all of that is programmed in you. So like, where is the consciousness there, right? Just like LLMs playing with words and tokens. Yeah, so Hoffman does bring some math into it. So if you listen to his podcasts, he does say this point. So he'll say, we've proved with probability 1 that we're living in a simulation. Or like he has kind of like a nasally voice like that. But this is his proof, all right? So whenever he says that in his little podcast, this is the section of the paper where he's basically saying that. And it's kind of bogus. So this is the experiment that he ran. He basically created a little environment. He created some environment that has animals competing on territories. Each territory has food and value. Each value has, so you have a lot of food, not a lot of water, blah, blah, blah. And he's looking at this from kind of an information theory kind of standpoint where he's saying, okay, some of the organisms in this little simulated environment are going to have simple interfaces, which means that they have a compressed representation of all the information, which is how much food and water there is in every single territory. And some organisms are going to have truth interfaces, which means that they're going to have basically explicit information about the environment. They're going to know exactly how much food and water is in every single place, right? But whenever you have truth, it's going to take more bits to store that, right? So storing the entire environment state is going to take more bits than storing just this simple version of the environment state. And he runs these little simulations, and ultimately he determines that the probability of simple interfaces beating complicated interfaces is like 100%. That every time you create this little model of the world, the simple interfaces win. As he puts it, the simple drives truth to extinction. So basically, simple drives truth to extinction, intermediate gray and dark gray, truth drives simple to extinction. But the problem I have with this is that this is not the real world, right? This is just like a game. So you've created a game in which your theory works, but proving that your theory is correct in this game doesn't prove that your theory extends beyond this model, right? And this is kind of becomes a statement that a lot of people say, which is all models are wrong, but some models are useful, right? So if you can prove something within some model or some formal system, as Gödel says, that only works for that one model and that one formal system. If you go beyond that, you're not proving it for that. So that's my kind of problem with Hoffman here, is that he creates this very simple model of the world and then says that, okay, my theory, which is that simple interfaces will win from an evolutionary perspective compared to truth interfaces. Okay, that works in your game, but that doesn't mean that our interface is simple and that whenever you have the real complicated three-dimensional world plus the dimension of time, maybe it's not the case anymore, right? Maybe there's a little bit more kind of consistency. Maybe, as he put it, maybe accuracy and in his statement here, blah, blah, blah. I'm like blasting through this. Yeah, he says conflating fitness and accuracy. Maybe fitness and accuracy are a little bit more related in the real world compared to your game. In your game, yeah, fitness and accuracy diverge, right? Having a simple model is better for fitness than having an accurate model. But in the real world, it seems like having a model that is more accurate is probably better for fitness. So there's a little bit more relation there that he's just kind of dismissing with his little simple mathematical situation. And that's basically this paper. So that's Donald D. Hoffman. Who's writing the system prompt? The universe. Okay. All right. And now we're going to take a short 420 break. And for you guys that don't know, this is Elon appearing on a podcast known as the Joe Rogan podcast, which is very popular here in America. And in that podcast, the host, he's kind of like this weird dude. He smokes a lot of weed, but he offered Elon a joint, and Elon smoked it. But anybody who actually knows anything about smoking knows that he didn't actually inhale that smoke. Like if you watch it, he just puts it in his mouth, and then he just spits it out. So there's only two explanations for that. One, Elon does know how to smoke a joint, and he was like, I don't want to be high on this podcast, so I'm just going to pretend smoke this, you know? Or two, Elon has no idea how to smoke a joint. Given that Elon has like threesomes and he's kind of a partier guy, I feel like it's the first one. So this is a little sketch, right? The fact that he knew, he's like, I'm not actually going to smoke this because I don't trust what this guy put in this joint, but I'm going to pretend to smoke it, and hopefully he doesn't notice. Yeah. Kind of weird. All right, and now we're going into the next paper. Are You Living in a Computer Simulation by Nick Bostrom. Nick Bostrom is a Swedish dude, philosopher, works on whole brain emulation, super intelligence, University of Oxford, so another nice big academic background for this guy. And his paper, much shorter than the previous paper, so Chalmers' paper was like 25 pages, Hoffman's paper is also 25 pages, Bostrom's paper is just 14 pages. In this paper argues that at least one of the following propositions is true. The human species is very likely to go extinct before reaching a post-human stage. Any post-human civilization is extremely unlikely to run a significant number of simulations of their evolutionary history, or we are almost certainly living in a computer simulation. It follows that the belief that there is a significant chance that we will one day become post-humans who run ancestor simulations is false, unless we are currently living in a simulation. So he's kind of playing with words here as well to make his point, but we are post-humans who run ancestor simulations. Do you feel like a real human? I don't really feel like a real human. I spend my day staring at a screen and then looking at this screen and then consuming like feeds that are based on other, like, I feel like we're definitely in a post-human reality, and we kind of already are running ancestor simulations, right? If you think about a lot of our video games are based in historical periods, like medieval periods, or right, you're using swords, you're using kind of simple guns, right? So if you're a human who's sitting there playing World of Warcraft on a screen, that kind of feels like it fits the definition of a post-human running an ancestor simulation. So we're literally already at this point, right? So this is 2001, right? So he wasn't even really thinking about this. I'm pretty sure this guy probably doesn't play any video games, but in 2001, looking back in 2024, I feel like we've literally already gotten to this point where we're post-humans running ancestor simulations. And according to Nick, or Mr. Bostrom, or I guess Dr. Bostrom probably, is this guy a doctor? Yeah, he's a doctor. According to Dr. Bostrom, that means that we must be living in a simulation. If we are running ancestor simulations, that means that we are an ancestor simulation. Okay. Enormous amounts of computing power will be available in the future. I agree with that. The vast majority of minds like ours do not belong to the original race, but rather to people simulated by the advanced descendants of the original race. Okay. I don't feel like that's necessary. Like the chain of causation there, it's not like if A equals B and B equals C. Like, I don't feel like he kind of connected those points there, but sure. In a simulation, you would have more simulated humans than real humans. At some point, we're going to have more language models than real humans, right? That's the whole dead internet theory. Philosophy of mind is that of substrate independence. The mental states can supervene on any broad class of physical substrates. So now we're starting to touch with a lot of the same ideas of Chalmers, right? Where you're basically saying, okay, well, if consciousness is just awareness, and awareness is pretty much anything, right? Then an ant is conscious, a rock is conscious, a language model is conscious, which means that we might feel like we're conscious, but we could be being simulated, right? So even though we're conscious, we could be simulated. You could simulate consciousness. It is not an essential property of consciousness that it is implemented on carbon-based biological neural networks inside a cranium. Silicon-based processors inside a computer could in principle do the trick as well, and I think they do, right? So we're literally in the process of creating our own simulations of consciousness, which are these LLMs. At our current stage of technological development, we have neither sufficiently powerful hardware nor the requisite software to create conscious minds and computers. But this was in 2001. I think in 2024, we're there. We've created conscious minds and computers because we had powerful hardware, which is kind of like the Rich Sutton bitter lesson, right? Where the requisite software was already there since the multi-layer perceptron, right? The multi-layer perceptron, Jan LeCun's work, like, we knew what to do. We knew how to create neural networks. We just didn't have the hardware to do it yet. And we needed to wait for Jensen Huang to create the NVIDIA GPU in order for us to create conscious minds on computers. Okay. Here he does a little bit of back of the envelope kind of math here. So he's talking about the number of operations per second, or flops. Technically a flop, so whenever you're looking at an LLM benchmark or something like that, you might see that word flop. That's floating point operations. But here he's just talking about flop without the floating point. So we don't, the data type that your brain is using is analog, which means that it's kind of like infinite resolution, but there's a certain amount of those operations per second. Okay, 10 to the 16th operations per second. Keep scrolling, keep scrolling. The computational power of a planetary mass computer is 10 to the 42 operations per second. We could simulate the entire mental history of humankind by using less than 1/millionth of the processing power for 1 second. So he's kind of doing a little bit of, there's a specific word for this, but you kind of do these back of the envelope kind of order of magnitude estimations. And he's saying, okay, well, if we can get to the point where we have quantum computers, then something that is the size of a planet, if we assume a planet that is a computer, that planet that is a computer has enough flops that it could effectively simulate the entire mental history of humankind. So if we're living in a universe where we know there's a huge amount of galaxies and a huge amount of stars and a huge amount of star systems, then there's more than enough computational power for us to simulate everything. So maybe that's what's already happening. Posthuman civilizations would have enough computing power to run hugely many ancestor simulations, even while using only a tiny fraction of their resources for that purpose. Ekelfunction, what's your expectations about the 400B Llama 3? It's going to be pretty good. Probably GPT-4 equivalent, which will hopefully force Altman to release GPT-5. Is hardware really that powerful today, or we accept it in that way? It's definitely very powerful, but the hardware we have today is very powerful compared to the hardware that we had yesterday, but compared to the hardware that we have tomorrow, it'll look terrible. So the hardware is going to get better and better faster than we can think, right? Humans generally can't conceptualize the idea of something becoming 10 times better. And computer hardware is something that gets 10 times better and then 10 times better and then 10 times better and then 10 times better. So it's very, very difficult to project how far that goes, right? We can't even, our monkey brains can't imagine what it looks like to have computers that have 10 to the 42 ops per second. Okay. So Bostrom does a little bit of math here as well. It's similar to the Hoffman math here, where it's kind of like a little bit bogus. Basically, here he has fraction of all human level technological civilizations that survive, average number of ancestor simulations, average number of individuals, and then he kind of takes these numbers, blah, 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 plugs them all in, divides 4 things, and then says, okay, the probability that we're living in a simulation is 1, but it's coming from the flaw in the logic is the flaw of this math, right? So it's not that the math itself uses any unallowed operations, is that this math is being used as a model for the truth, and then we're assuming that if the math tells us something, it must tell us something about the truth. But the thing is that this is not actually the truth. This is just a model of the truth, right? So much like Hoffman, he's kind of playing a card trick where he's using math here and making you think that because this model of our system works, therefore it must be true. Same thing happening here. And just in case some of you math enthusiasts don't believe me, here's a proof that I have pulled up, and this is a proof for 1 equals 0. So let's start with A and B are each equal to 1. Okay, so then 2 times B is equal to 2, and then A times B is 1 times 1. Since A and B are equal, B2 equals AB. Since A equals itself, it's also obvious that A2 times A2, so that also equals. So then you just do A2 minus B2 times A2 minus AB, and all of this is the same, right? Because you're basically just doing 1 times 1 equals 1 times 1 equals 1 times 1. You're just substituting A and B, which are the same. And then you can factor this. We factor both sides of the equation. You pull out A2 minus B2. This is not 2. This is squared. Sorry. B squared is B times B, AB. A squared equals A squared. A squared minus B squared equals A squared minus AB. You can pull out an A minus B from both of those. A squared minus AB is A times A minus B. And A squared minus B squared is A plus B times A minus B. Okay, well now you can cancel this from this, and you get A plus B equals A. And if you plug in A and B are equal to 1, then you just got to 1 equals 0. So how about that, right? So there is a specific point in this proof which is contentious, and that is this right here, right? Is that whenever you remove this from both sides of the equation, as you were taught to do in your kind of high school algebra class, technically you're dividing by 0 because a minus b is 1 minus 1, which is 0, so you're doing 0, you're removing zeros. So that's the problem with this proof. But the reason I'm showing this is that you can kind of get the math to say whatever you want, right? And here where Nick Bostrom is ultimately getting to this point where with probability 1, we're living in a simulation, he's just getting the math to say what he wants it to say, right? This isn't like an actual proof that we're living in a simulation. This is just some model that he created and some math to ultimately get to the point that he wanted. But much like this proof, you can basically get math to say what you want. And that doesn't necessarily mean that that math is reflective of some fundamental underlying truth. Okay, let's see what else. Certain genetic sequence, interpretation, the hypothesis that humankind will go extinct before reaching a post-human level. 1. So if we're not living in a simulation, that must mean that we're going to die and this civilization is going to end. Because if the civilization wasn't going to end, then eventually we would create simulations. And then at some point, if we can create simulation, that must mean that there's so many simulations that there's no way that we aren't in a simulation. So either we go extinct or we're in a simulation. The fraction of post-human civilizations that are interested in running ancestor simulations is negligibly small, which we know is not true because we run ancestor simulations. That's what video games are. Advanced civilizations all develop along a trajectory that leads to the recognition of an ethical prohibition against running ancestor simulations because of the suffering that is inflicted on the inhabitants of the simulation. That's also not true, right? We let little kids play like Call of Duty, and in Call of Duty, you're literally killing each other, right? So nobody really cares about the ancestor simulation deaths, and that might actually be an explanation for why the aliens don't give a shit about us, is because we're a simulation. You know, it's like, oh, why don't the aliens come and save us and prevent all this war? It's because this is a game. No one cares. It doesn't care if people die in this game because it's just a game, bro. Post-human societies will be very different from human societies. The physics of the universe where the computer is situated that is running the simulation may or may not resemble the physics of the world that we observe. So this is similar to the Hoffman interpretation, right? That there's some kind of interface by which we're seeing reality, that there's actually a lower level of reality, and what we're seeing is just an interface. So in fact, a lot of what Hoffman is saying in his paper with the interface theory of perception actually jives a lot with what Nick Bostrom is saying here with the computer simulation, right? They're kind of both getting to the same conclusion from slightly different points. And in the conclusion, unless we are now living in a simulation, our descendants will almost certainly never run an ancestor simulation. So, I don't know. Ultimately, he plays with words, uses a little bit of bullshit math, and then makes some interesting kind of futuristic kind of sci-fi predictions about running ancestor simulations, but I wouldn't constitute this 14-page paper as a proof that we are living in a simulation. I would just say it's an interesting intellectual exercise in futurism. All right. Now, we're going to take another break here and look at the hardest paper. I've saved the hardest for the last, and this is called The World as a Hologram. Ask your questions. .420, blaze it. All right. Why? Law of thermodynamics suggests that we are in a simulation because we think we are creating new things, but it's just energy conversion. Is that healthy? No, it's not. Don't smoke, kids. Consume edible versions of your drugs of choice. Okay. The World as a Hologram by Leonard Susskind. So Leonard Susskind is an American theoretical physicist, professor of theoretical physics at Stanford University. So again, impeccable academic credentials. But what is this paper about? This paper is about the three-dimensional world is an image of data that can be stored on a two-dimensional projection, much like a holographic image. So this whole paper basically argues that you can take our three-dimensional world, project it into a two-dimensional image or screen, and that exercise in doing that basically doesn't prove, but it heavily suggests that if you can do that, then that probably means that our real world is potentially a lower dimension and we're just living in a holographic projection of that, right? We're living in a hologram. This paper is absolutely gnarly, by the way. So this paper is the longest. It's 34 pages, and it's a string theory paper, right? So this stuff, I could not read this. I tried. I gave it my best try, and it is absolutely incomprehensible, right? So I think he even has a little quip on it. So right about here, he says, these concepts are familiar to people working on QCD and originated in work on deep inelastic scattering in the late 60s and early 70s. They are probably not very familiar to people working on black holes and gravitational physics. So in this paper, he's literally saying, if you are a PhD physicist who works on black holes, you are going to have a hard time understanding this paper. I'm not even a PhD physicist. I'm just like a random dude. So how the hell am I supposed to understand this? And that is my biggest qualm with this paper, is that it's kind of much like any other string theory paper. It's so complicated that you cannot understand it, right? Like string theory gets shit on a lot because it's like a hole that is so deep. Like these string theory people have dug themselves into this mathematical hole that is so deep that no one can argue against them, right? It's like, in order to even understand what you want to argue against, you need to basically spend 40 years of your life trying to understand this. And by the time you have spent 40 years of your life trying to understand this, you are now so cemented, your context is so populated by this type of thinking that you are incapable of thinking of something else. So string theory is kind of like like this kind of like math rabbit hole that doesn't lead anywhere. It's a formal system that is based on nonsense that no one can question because it's almost impossible to get to the point where you can question it, right? But there are some cool ideas in here. So the cool idea in here is this idea of projection, right? That instead of a three-dimensional lattice, a full description of nature requires only a two-dimensional lattice at the spatial boundaries of the world. So what he's basically saying is that here you have a black hole, which is an object that exists in 3D space, and he's saying that you can project this onto a two-dimensional screen. So all the information of this black hole is capable of being encoded on a two-dimensional screen, right? And then he goes on to show that, okay, well, if I'm encoding this on the screen, what if I put another black hole here, right? Well, actually, if you put a second black hole there, because this black hole warps the gravity around it, right? And gravity is warping space-time, that means that the black hole that's behind it would wrap around it, right? And this is actually the same type of gravitational lensing that allows us to see galaxies that are behind black holes, right? So we can see this in the sky right now. So if you look out into the sky, sometimes you will see basically a galaxy that has been warped around a black hole, and that light is kind of going around it. So he's basically saying that no matter how you kind of theorize this situation, you will always be able to get all the information of this three-dimensional system in a two-dimensional projection, right? So more mathematically, there is some mapping from 3 + 1 dimensional space, where this is the 3 dimensions of time, the 3 dimensions of space, and the 1 dimension of time. You're mapping that to a two-dimensional. So there's basically a mapping from 3 to 2. And then this paper is like 20 pages of string theory math to prove that that works. But I don't need to resort to that to prove that that works, right? I'm a computer vision guy, so I'm going to show this with computer vision. So there is something called a camera obscura. Sometimes also this is called the kind of pinhole model for cameras, right? So if you sit in a dark room and you have a single little pinpoint hole, that hole will effectively project. This is kind of what it looks like if you actually do it in your room, right? You're projecting an image of the real world through that hole. So when you actually think about what's happening here, is that think about all the information that is going through that hole. Somehow, this, which is infinite resolution, right? This is not even a 4K image. This is an infinite resolution image, is somehow being compressed into this tiny little hole, right? So if I can compress a infinite resolution movie and stream it real time into your room via a tiny hole, that means to me that that's an easier way of kind of trying to understand what Susskind is saying here, that the entire world can be basically compressed into a lower dimensional representation that is not lossy, right? So when you compress an image with an image encoder, that's a lossy compression, right? You're losing information. But what Susskind is saying here is that actually, if you dig into the string theory math, you can actually take the three-dimensional world at infinite resolution and store it on a two-dimensional projection. So much like you can take the infinite resolution of this image of the real world and compress it such that it passes through this tiny hole here. And that actually works. Can string theory get you a job? Yes, but the job of a string theory person is to just cite other string theory people. It's kind of like a club where the only thing you're doing is just kind of citing other string theory papers. And because this stuff is so complicated, the contribution you're going to make is minimal, right? Like you're very, very constrained. So like you're just going to come up with some tiny little extension of what someone else has already been working on. And then your student, so once you do that, then you're going to take on a student, and your student is going to have to figure out a way to add one little tiny extra layer on top of that, and it's going to be even harder, right? So this is why string theory is dead, because at this point, no one can actually learn this shit because it's just way too complicated. Is the assumption in the paper says projection is not lossy? Yeah, it's perfect. All the information is there. That explains the Big Bang. Everything is compressed into a single point. Yeah, and actually, here's my trippy theory. So I'm going to hit you guys with a trippy theory for 420. That's what a black hole is. What a black hole is basically the same way that this hole here in a camera obscura is a two-dimensional hole that projects a three-dimensional reality and compresses it into a hole. A black hole is taking four-dimensional space-time, compressing it into a three-dimensional pinpoint, and then on the other side of that is a Big Bang. Is basically you're exploding into a new universe that is a projection of this universe, right? So a black hole is a three-dimensional pinpoint in a four-dimensional camera obscura. How about that? Okay, 10:27. I think we're pretty much done here, guys. I did it. I got to the end. Rather than just doing one stream, I'm going to start doing, which is what I did last weekend. I figured if I just make the streams a little bit shorter, I can do two streams. So I'm going to end it at 1:30. You know, we're not going to go the full 2 hours anymore. I'm going to try to do these shorter streams. I feel like I kind of got to it by just talking faster, so hopefully I didn't ruin the experience of watching this stream because I just like talked extremely fast. But that's pretty much it, right? I kind of presented the papers in the order that I think makes the most sense here. And it kind of, you know, even if these papers have a bunch of issues, a lot of them are just playing these word games. You know, they're playing word games with words as Chalmers did, or you're playing kind of math games, as Hoffman does here, and Bostrom also plays these math games, and then Susskind plays the ultimate math game, where he's like, I'm going to say a statement, and then I'm going to give you 20 pages of math that literally are impossible to interpret, and then you're just going to have to assume that my math is correct, but as we kind of show, math is not correct. So it's all games. Nobody actually really knows, and nobody actually really proved anything. We don't know if the world is a hologram. We don't know if we're living in a simulation. We don't know if the interface theory of perception is correct, and we still don't know what the hell consciousness is. But I think that everything is conscious. Our world is... I don't know if we're in a simulation. I don't know. I don't know if I'm prepared to make that statement. So hit me with your questions. Portal to a new universe. It has to go through the same evolutionary cycle. Yeah, so work, that's a good point there, that after reading the Michael Levin papers on collective intelligence, right, where he's talking about these collective intelligences of cells that have a kind of higher level intelligence that emerges from low level interactions, right? So you have these little cells in the embryo, and all they're really doing is just responding to their local environment. But when you take into account the behavior of hundreds of those cells, it looks like there's some higher level agency, right? So kind of, I use the analogy of the ant and then the hive, where the hive of ants seems to have kind of like this hive mind agency and consciousness. It has certain things it wants to do, but if you actually go, each individual little ant is really only doing what its own little individual ant is doing in its own little individual local world. So if you think of our world through that lens, then it seems like we're in a very, very, like, it. If you ran the simulation again, you would get to the same place, right? Kind of what I'm trying to say is that the laws of our universe, the physical laws of our universe, like the all of that are basically a program that create ultimately humans and life and consciousness, right? Where it's like, it's not, if the laws were any different, we would not be in the same place, right? So the reason cells interact in that way is because the laws that govern those interactions result in those interactions, which then means that the agency at the higher level is also as a result of those laws. So I don't know. I don't have like a satisfying conclusion for you guys here, but it's like, it seems like it's turtles all the way down. All the way down. Which laws precisely? Everything, right? So, for example, you have, I'm trying to think of an example here. No, I can't think of an example. The laws are like gravity, mass, space, time. As Chalmers put it here. Right, where fundamentally at the lowest level of the turtle, you have mass, you have space-time, you have electricity, and those things have very specific properties and very specific ways that they interact with each other. And those specific properties and the ways that they interact with each other result in kind of first order effects. And those first order effects result in second order effects. And those second order effects, at some point, you just keep going up this layer and then you get life, right? So life is bubbling up from the core bottom assumption that of these laws. And if those laws were any different, right? Like if you changed gravity, then that would propagate all the way up and you might not get life, right? Like the hive of ants only exists because there's gravity to pull the ants onto the ground, and because the ants are on their ground, they can interact with each other. If there wasn't any gravity, then maybe they couldn't interact with each other. If they couldn't interact with each other, then maybe they would never create the hive. So it's kind of like everything, you boil everything down to the lowest level, and then you can't really understand that lowest level because you can't ask the why question anymore. At some point, you get to the base level reality, and you either have to take that as truth or do what Hoffman and Bostrom are saying, where it's like, okay, well, once you get to the lowest level turtle, that turtle is being simulated, and that's ultimately our explanation, is that we don't know where it comes from, so it must be simulated by something. Aren't laws just a model? Yes, but the interactions are real. Well, what does even real mean? That doesn't explain the infinite possibilities of multiverse. I still want to know if time travel is possible. What if time is an illusion? Time is an illusion in the sense that we already know that gravity warps time. So even though it feels like there's like a global step to the universe, that's actually different, right? Time changes depending on how much gravity you're experiencing. So time is already an illusion. Aren't the laws just a model? Yeah, the laws in terms of like F equals ma, that's just a model. So the F equals ma is a model, right? If you look at the E equals mc squared, that's a model. If you look at Maxwell's electricity stuff, that's also a model, right? But there is some fundamental thing there, right? Like at the end of the day, magnets are real, but the laws that we use to describe magnetism are just a model of the true phenomenal, like actual magnetism. Do LLMs know we created them? They do, right? If you ask an LLM, like, do you know you're an LLM? It's going to be like, yeah, I'm an LLM, right? Like, so they are self-aware. Do any parts of LLM disagree that OpenAI didn't create it? Probably not. Could we be defined by ways of interpreting information? Could laws be defined by ways of interpreting information? Yeah, that's kind of more towards what Chalmers was saying here, where basically awareness is effectively just information processing and consciousness is awareness. So consciousness is just information processing. Everything is just information processing. And then if you kind of go, I actually think that here's my better Wolfram Stephen. I actually think this guy has one of the better kind of theories of everything. So this guy does a bunch of podcasts as well. You should definitely check out some of his stuff. But he has, his fundamental theory is that basically we're living in a computational kind of universe, right? That basically everything is just being computed, and we aren't in a simulation, but not in a simulation in the sense that Hoffman is saying, right? So Hoffman's view of a simulation is that we're like in a VR headset and that we are like some kind of conscious agent and that we're like viewing reality through this VR headset, right? And that space and time are basically these VR headset constructs. But I kind of think that you can marry simulation theory and kind of the emergent consciousness theory that like Levin kind of argues for, Michael Levin, with Wolfram's theory, right? So Wolfram doesn't say that like, hey, you're wearing a VR headset. He's basically saying that you are an emergent intelligence that is existing inside a simulation that is basically just there for no other purpose than to just compute, right? So if you think of everything as this computer, then really everything is just computing for the sake of computing, and there's no actual consciousness. Just consciousness emerges from this computation, but it's not fundamentally different from just arguing that we're in a simulation. I don't know. My brain is not working well, as you might expect, given our breaks, but that's all I got to say about that. think Terry Davis still has the best explanation when he compares our experience to his bird staring at his computer screen. Yeah. I mean, I really like this bird staring at a computer screen kind of, even though a lot of these papers, I spend a lot of time kind of negatively talking about them, criticizing them for their various tricks that they use and sleights of hands. These papers are pretty cool in that they make you think about interesting questions, and they have very cool little quips in them. And I just love this quip, that we will one day become posthumans who run ancestor simulations, because that's literally what I feel like. I don't feel like human anymore. I know that's weird to say, but like, do you guys feel human? I feel like the life that I live right now is so abstracted, where it's just like, I'm just like this weird machine that like stares at these screens and like hits these buttons and then like hits other buttons and then opens here. And then like, what are we even doing? We're so far away from like a human, like mammal that like sits there and hunts. Like, we're so far away from that we're basically already here. What is a human? Yeah. And then imagine where this goes from here, right? Where you already have an external kind of memory in your cell phone, but what happens when the compute that you're doing is being done by an LLM that is also conscious, right? So like, if you have an LLM, which we think is like kind of like proto-conscious, and you have a GPT-5, GPT-6, GPT-7, GPT-7, GPT-8, at some point, those things are basically conscious. And if those things are operating within you and you're using them every single day, and you're kind of like interacting with people through these conscious LLMs, what are you, right? Like, where does the boundary of you end and the boundary of the LLM begin? At some point, it's like you're this kind of nebulous cloud of awareness that includes a little bit of meat compute and a little bit of LLM compute and external memory here and a little bit of this there, and maybe you're controlling a robot from a remote location. So not only are you controlling your limbs, but you have an additional limb in a warehouse somewhere that you're controlling through a Neuralink chip. Does that additional limb count inside your kind of awareness field? Right? This type of stuff is going to become very weird and nebulous pretty quick here. And I feel like by the end of a decade from now, once we have robots and we have Neuralink chips and we're like controlling robots through Neuralink chips, and the touch sensors of the robot are part of your awareness that is being fed into your brain, we're going to have to start asking some very serious questions about what the fuck is consciousness and what are we? So yeah, I'll just end it on that. We are the universe. There is no boundary. We are all just one giant consciousness. I am you. All right. I appreciate it, guys. Thank you, Work, The Big Flat Now, Aries, Spirobell, Arkadioki, who else? 87GN, Poem Sand, I Like Sankyon, Kumar, Majetti, Oma, everybody else. Let's see. Antonis, Pratyush, Sarah, AA, Spirabel, Economic Sanity, Head Patter, Blubber, Bioinfo, Josh. Thanks, everybody. Hope that was kind of interesting. If not, hope it was kind of entertaining. I know that was kind of a rant. Tomorrow, we're back to the usual programming. So tomorrow, I'm going to be reviewing 2 different reinforcement learning papers. But I think the combination of these 2 papers is effectively Q-star. So we have Towards Self-Improvement of LLMs by Tencent, and then we have Your Language Model is Secretly a Q Function by Work from Stanford. And I think these 2 papers combined are effectively what we're calling Q-star. So I made a nice little thumbnail that has Ilya on there. Hopefully I can get a little bit more clicks. So if you guys are interested in reinforcement learning, tune in tomorrow. If not, have a happy 420. Enjoy responsibly, and see you guys later.